This is part 6 of section 4.1. And we want to find the distance between Chicago and Pensacola, Florida. Chicago, Illinois is due north of Pensacola, Florida. So, and we're given that we want to find the distance between them. And we know that Chicago is located at 41 degrees, 51 minutes north. And Pensacola is at latitude 30 degrees, 25 minutes north. Since they're due north of each other, we don't have to worry about any left, right, east, west movement at all. And we can treat this as one giant circle. We are told to use our radius of the Earth as 3,960 miles. So if we think of this as a circle, the distance between the two is going to be the arc length, okay? So the first thing I have to do is to figure out this angle right here, okay? And so I take 41, except I can't write, 41 degrees, 51 minutes, and I'm going to subtract away 30 degrees, 25 minutes. Now, if you need to do a borrowing just like you would in time, so if this number were 52, then I would write it as 40 degrees and then add 60 here so I could do the subtraction. But this works nicely, and you get 11 degrees, 26 minutes. So that's how far apart these two cities are. That's the angle formed by them. And we have to have our angle measurement in radians before we can use the arc length formula. And what's more, I need this in decimal degree notation, not degree minute second notation. So I'm going to convert this to decimals first. So I would have 11 plus 26 over 60. Which gives me approximately 11.4333 degrees. Okay, now I want to convert this into radians. So I take 11.4333 degrees, and I'm going to multiply this by pi over 180. And since I have this written exactly in here, I'm just going to keep it in my calculator. We're going to end up rounding at the end anyway. So if I multiply by pi and then divide by 180, I get approximately this many radians. So I'm going to write down that this is approximately 0.1995, and let's go 49, just to make sure I have enough digits. Okay, so now I have the angle. This is my theta right here. I have that in radians, which is what I need. And I have the radius, so I can find the arc length, which is going to be the distance between these two. S is equal to r theta. So S is equal to 3,960 times 0.199549. And I'll just use this exact in my calculator and multiply. And we get that it is approximately 790 miles. These two cities are approximately 790 miles apart. Okay, so we've just talked about how to find an arc length. Another thing we will often be asked to do is to find the area of a sector. So if our angle is like this, and we want to find the area of just this portion of the circle, then we use area is equal to 1/2 radius squared times theta, and again, theta has to be in radians. Okay, so let's find the area of a sector of a circle of radius 10 inches formed by an angle of 60 degrees. And then we want to round to 2 decimal places. Again, I am given an angle in degrees. I need it in radians. So our theta is 60 degrees. We're going to multiply by pi and divide by 180. And that gives me exactly pi over 3 radians. Okay, so now let's find the area of a sector. A is equal to 1/2 our radius squared, so that would be 100 times pi over 3. So the exact answer here is 50 pi over 3. Which is approximately 52.36. And this is an area, so it is inches squared, or 52.36 square inches. Okay, one more topic, linear and angular speed. So suppose an object travels around a circle of radius r. If the object travels through a central angle of theta radians, again we're in radians, and an arc length s in time t, then we have these three relationships. Our v is approximately s over t. That is our linear speed. Okay? This is the Greek letter omega. Omega is equal to theta over t is the average angular speed of the object. Okay, now we have this definition here for s, and if we take this and we plug it into these two, we get a simplified version right here. So the linear speed is equal to the radius times the angular speed. So let's look at one problem here. A model plane is attached to a swivel so that it flies in a circular path at the end of a 10-foot wire at the rate of 18 revolutions per minute, and we're asked to find the angular speed and the linear speed of the plane. So 10 foot is spinning around a 10-foot wire, so this is my radius. Okay. All right, and we're given 18 revolutions per minute. Well, one revolution is equal to 2 pi radians. Okay, so 118 revolutions per minute is the same thing as 18 times 2 pi, which is 36 pi radians per minute. Okay, now since this is in radians, that's our angle, and our angular speed is omega. So what we've just found is that omega is equal to 36 pi radians per minute. Okay, so we're asked to find the angular speed and the linear speed, and I can come up here and I could use any of this I wanted to, but right here we have something very nice. The linear speed, which is v, is equal to r times omega. So the linear velocity is the radius, which is 10, times omega, which is 36 pi. So this is 360 pi, and this is in feet per minute. Okay, and if they ask you to do an approximation of this, it's approximately 1,131 feet per minute.